Mhm. So, welcome to the second lesson. Today we are going to continue and complete a short excursion into finance. So, let's get started. At the previous lecture, we already discussed a problem connected with a profit and investment. As you remember, some person had $20 at the beginning period and $21 at the end of the period, and profit will be as difference between VT and V0. Yes, remember. And for example, this result was $1. And what can we say? Is it good result? Is it good profit? We can't say this because it depends from initial investment. Yes, you understand this. Um, so so we need to find a profit expressed as a proportion of the original investment. We denote the return as R capital, and in finance, a return R capital is a profit on investment expressed as proportion of the original investment. And we can divide it Vt by V0 and V0 by V0, and the result can be expressed as Vt divided by V0 minus 1. It will be useful for later. So remember, please. And a little example. Maybe I would like to take a pen. So if you hold 100 shares with a starting price of 10, then the starting value is 100 multiplied 10. It is clear, 1000. If you then collect half per share in cash dividends and the ending share price is 9.8, then at the end you have result 100 multiplied 0.5, it is 50 in cash, plus plus 100 multiplied this price, and totaling final value of this result you see. And after that we can find this change. Maybe I write this because it is more convenient. V0, what is our initial original investment? It will be, we bought 100 shares with a starting price 10, so it is 100 multiplied 10, and this is 1000. Yes, and at the end of period, what will be a result? What will be a result from what is result from shares? From shares, the starting price was 10, but but at the end period, the price is, you see, 9.8. It is less than initial period, yes, but anyway, so it is, we have 100 shares multiplied this price 9.8, but it's not all, because we have dividends. It is this from every shares, it is $half. So plus 100 multiplied 0.5, and it's easy to compute that the result will be 1.013. So we can compute this return for this formula as proportion. You remember from the previous slide. So 1.30 minus 1000 and divided by initial investment, it is 1000. This point or result point, you understand. So it will be 0.003, and I can write this as 3%. So return is, in this example, is 3%. And my question, is it a good return? Is it a good return? And I think that it's just a little tricky question. Who would like to answer?
So it depends on the alternatives we had.
It depends on
alternatives we had.
On alternative. What do you mean? You mean that you would like to compare with
Yeah.
Yes? Maybe maybe you mean that you would like to compare with interest rate in the bank, yes?
Yes, with more safe alternatives, with more risky, yeah.
Yes, but I wrote that it's a tricky question. And tricky, it means that in this example, we don't know about time period. Understand? You see, this example, we don't know anything. It was 1 year or 1 month, but I agree. It's very important. Or do you agree? Do you agree that it's very important?
Yes.
Yes. So thank you. And we found out that time is very important. So we need annualization, and it's really the aim to compare, but to compare returns over time period. No, we need to know what is time period. To compare return over time period of different lengths on an equal basis, it's useful to convert each return into an annual equivalent rate of return. Yes? It calls annualization process, and a return is called annualized return or effective interest rate. Do you understand what is difference between return and effective return or annual return? It is that it is for 1 year. So how we can find rate of return? R capital, it's return, yes, but R little, it is rate of return, or it's called rate of effective. There are two formulas, without any reinvestment and with reinvestment. Without, it's very simple. We only divide our return by T, and that's all. So it's formula number 1. And we can illustrate this using this example. Initial investment initial investment was $100,000, $100,000, and at the end of period it will be no 20,000 return, so it will be 120,000. So the return is proportion, you remember. In numerator we write difference, profit, net profit, but in denominator we write initial investment. So it is 20 divided by me, and in the percent it will be 20%. Yes. So with this everything is clear. But what is return? Return it's a little, and using this formula 1, it is only 20% divided by 5, because we have 5 years, so it will be 4% for 1 year. And it's simple, yes, it's easy. Do you have any question about this example? Igor, do you have any question?
No, not me.
Thanks. And my question to you, what was this formula? What is rate of return if you will take to account reinvestment? What does it mean? What does it mean? It is we would like to take to account the effect of compounding. What is compounding? It is generated earning from previous earnings. Maybe you know about this. Yes, it's compounded percent. It's compounded interest rate. Yes, so we need to find the relation between R little and R capital over a period of length t. So we need formula which gives us a link between R capital, R little, and T. Yes, and maybe the investment at the end period and at the initial period. So this formula, it's just formula of compounding interest rate. Yes, and for this formula we can find R little. It's easy. We divided the both sides by V0, and after that we find the root, and R little, it is this formula. But you remember that Vt divided by V0 from first slide, yes? Vt divided by V0, it is R capital plus 1. So the formula 2, which gives link between R little, R capital, and length t, is in the form. Yes, you see. So if we remember the example, previous example, this example, yes, and R little rate of return was 4% per year. if it and it was without any reinvestment. By this formula, it will be 0.2 plus 1 to the power 1/5 minus 1, and it will be 3.7%. So it is different, but not the same. It is 4, and this 3.7. So we know two formula. Formula 1, it is return without reinvestment, and formula 2, it is rate of return with reinvestment, or it's called effective return. And the formula 2 can be used to convert the return to a rate of return. No, it's easy. From formula 2, we can receive our capital. We can get our capital. Yes. And my questions is, what's about periodic rate of return, about and continuously rate? It is the cases where the period of compounding we divided by some equal periods. So the formula 2 can be can be used to obtain periodic rate of return. What I want to write formula 2, but for periodic compounding. By periodic compounding, I can use all of this formula or this formula. Maybe I use this formula. So if you want, I can rewrite this. So the formula 2, it is with reinvestment. It is R liter equals VT divided by V0 in the bracket to the power 1t and minus 1. So if we have a periodic rate of return, so this expression in brackets we can rewrite as we know the formula for periodic compounding, and you used it in problem set, so it's formula V0 multiplied 1 plus R divided by N and V0 R divided by N to the power M T. No, maybe T capital or T little, it doesn't matter. So it's crossed, and we have from this formula R liter equals, so in this bracket this expression, and to the power 1 divided by t, so it will be, who would like to say this formula?
1 plus R divided by M in power of M minus 1.
Well done. So thank you very much. So we get this formula for periodic rate of return. And we can to do the same if we would like to get for continuous rate. Vt divided by v0 this formula you remember e to the power rt capital, it's closed, and what this formula looks, who would like?
Yeah, in power of r minus 1.
Minus 1. Well done. Well done. Good job. Thank you. And we have this formula. So, clear. And move on to the next slide. And next slide, it is logarithmic or continuously compounding return. What does it mean? Very often we use logarithmic return for researches of financial series. It's so it's natural to use this formula. It is amount at the end period. It is initial amount. We find this ratio, and after that, logarithm of this ratio. Yes. If you would like to get the rate of return, in this formula, you see, we just divide by t, and it will be formula 5. But what is interesting, that if we consider the equation, you see that it's equation of compounding continuously interest rate. No, you know this formula, yes? You know this formula. So from this formula, we can find this R little. So this e to the power equals Vt divided by V0, yes? And Vt divided by V0. And after that, we can find a logarithm the both sides, and we get the formula R logarithm Vt divided by V0. And all of this divided by t, yes? Do you understand how we can get this formula from this, yes? Igor?
Yes,
Yes.
I do.
Thank you. And if we compare this formula from formula 5, it is the same, you see, yes?
Yes.
So logarithmic return is the solution of this equation. Where is my cursor? The problem with y at the end. Oh. And we can illustrate this using this table. On this table, you can see comparison of ordinary returns and logarithmic returns for initial investment of $100. Yes, you see that $100 is always, but final investment is different. $0, $50, 99, 100, 101, 150, and $200. Yes. If we would like to find only profit or loss as a difference between value at the end of period and initial value, it will be in this case minus 100, this minus 50, this minus $1, this only 0, in this 101 minus 101, 50, and in this case 100. So ordinary return, it is a ratio, it is 100 divided by initial investment. So in this case, this ratio is 1, but in the percent it is minus 100%. In this case, it is this divided by this. It is a ratio with minus half, but in percent it is this, and so on. It's clear, yes? And if we would like to compute logarithmic return, we can use this formula. We can use this formula, and logarithmic this formula 4, and it will be different values, and it's worth to mention that for ordinary return, these values are symmetric, -1 and 1, -50 and 50, but for logarithmic return, it is not symmetric, it's different values. And that's all about return and rate of return. And the second, what we need to know, it is cash flow. I don't know why we have limited Zoom, but if interrupted, I will send you another invitation. Agree? So about cash flow. What is cash flow? Cash flow is just a series of payment, and it will be payment with plus, with minus, and different equals and different time period between this payment. But perpetuity is a stream or series of equal cash payments and at regular intervals, and that continues forever. Understand what is perpetuity? So it is as this, but everything, everyone payment is A, and continues forever. And we have regular intervals. What it can be? It can be, for example, consoles or preferred stocks, which pay your holder equals payment at regular interval and forever. What do we want? We would like to find what is present value. So what is present value? It is initial investment. What can be initial investment which allows this series? Do you understand what is problem? Do you understand what is problem? So we would like to have this string. We would like to have this string, and we need to find out what is initial investment, what is present value. For example, I have present value, some present value. It is $100 or 1 million, we don't know. And at the end of first year, at the beginning of the first year, at the end of the first year, we have present value multiplied 1 plus r. But we would like to have this series, this string, so we have we would like to have a at the end of the each period. So we should to give a, and we need to get the same present value, because everything will be repeat. At the end of the second year will be this present value. At the beginning of the second year, at the end of second year will be again this value, and we again should to give a. So it is a first, this is a second, and as a result present value, and again present value, and so on. Understand? So every year we have this equation, and from this equation we would like to find present value. So the present value multiplied to 1, present value multiplied r capital, and minus a. So present value we have on the left side and on the right side, and from this we have present value multiplied r, and minus r to the right side, so it's a, and from this present value equals a divided by r liter. Is it clear?
Yes.
Yes. Oh, thank you. So we know this formula, and we can illustrate this using this example. So what is this example? This example about console, UK government war loan console, and